We generally think of the boundary between the mind and the physical world as like an absolute wall.
Oh yeah, a total separation.
Right. On one side of that wall, you have pure thought. So the abstract, immaterial realm of logic, numbers, imagination.
Stuff happening entirely inside your head.
Exactly. And on the other side, you have the tangible universe. Stars fusing hydrogen, tectonic plates shifting, electrons jumping between energy states.
The physical reality we actually bump into.
Yeah. But sitting right on top of that wall is this paradox that the physicist Eugene Wigner famously called the unreasonable effectiveness of mathematics.
Such a great phrase, the unreasonable effectiveness.
Because it really is unreasonable. Why does this abstract machinery stuff, dreamed up purely in the human mind, flawlessly predict the behavior of the physical universe?
It remains, honestly, one of the most profound epistemological problems in modern science. I mean, you have mathematicians who just sit in offices developing topological frameworks or non-Euclidean geometries purely for the intellectual challenge.
Right, like playing a game.
Exactly. With zero intention of describing the physical world. They are literally just pursuing internal logical consistency. And then sometimes almost a century later, a physicist trying to explain, say, the curvature of space-time.
Or subatomic particles.
Right. They realize that the exact mathematical structure required to make their physical theory work is just sitting there, already fully developed by someone who was essentially just playing a complex game of mental chess.
It intuitively feels like a massive cosmic coincidence, because I think the prevailing modern mindset assumes that math is merely a descriptive tool we invented. Like language.
Yeah, we use English to describe a tree, but we don't think the tree is, like, fundamentally made of English.
Exactly. Yet when we use calculus or differential geometry to describe quantum mechanics, the universe doesn't just tolerate the description. It adheres to it with impossible precision.
It's eerie.
It really is. It's as if the mental architecture of mathematics and the physical architecture of, say, a black hole share the exact same underlying DNA.
And, well, exploring that shared DNA is our objective today. For you listening, we are taking a comprehensive deep dive into a really groundbreaking new monograph by Philip Lilien.
It's titled The Coherence Architecture of Mathematics. Galois, Ramanujan, and UCTE.
Right, and UCPE stands for the Unified Coherence Theory of Everything, which is quite the title.
It's a bold claim. But Lilien is presenting a framework that doesn't just try to build a better mathematical model of physics. He attempts to completely redefine the ontological ground floor of reality itself.
Yeah, the central thesis of UCPE is something we really need to parse carefully. He argues that reality is not just this vast, randomized bin of isolated objects bouncing off each other under imposed rules.
Like billiard balls on a table.
Yeah, exactly. Instead, reality is a coherence architecture. It's a layered, inherently lawful, and generative expression of a single underlying substrate.
And what makes this monograph so compelling, I think, is how Lilien actually proves this thesis. He doesn't just rely on abstract philosophy. He uses two historical mathematical titans as our sort of conceptual gateways.
Évariste Galois and Srinivasa Ramanujan.
Yes. And these two figures represent complete polar opposites in mathematical methodology.
Total opposites. Galois, the 19th century French prodigy, is the undisputed master of hidden structural symmetry. His work looks inward.
Identifying the invariant scaffolding, right? The stuff that holds a system together.
Exactly. And Ramanujan, the self-taught Indian genius of the early 20th century, he operates at the complete other end of the spectrum. He's the master of explicit, surface-level law.
Producing these terrifyingly complex formulas that seem to just arrive out of the ether.
Yeah, entirely bypassing the procedural steps that traditional mathematics relied upon.
So we have the master of the hidden architectural blueprint and the master of the visible, inevitable result. And Lilien's argument is that Galois and Ramanujan were not just doing different types of math, they were basically excavating two distinct faces of the exact same coherence architecture.
Right. But to understand this, we can't just skip straight to their equations. We really have to start where Lilien starts, which is the foundational blueprint of this reality.
He calls it the generative ontology.
And it is essential to grasp this ontology before we even touch a number or an equation. An ontology is just a philosophical study of being, what it fundamentally means for something to exist.
Right. And UCTE proposes this rigorous five-stage generative sequence that dictates how anything, whether it's an abstract mathematical concept or a physical particle, comes into stable existence.
Let's interrogate those 5 stages.
Okay, so the absolute foundation stage 1 is simply called coherence.
Lilien defines this as the invariant relational ground.
Now, usually when people hear the word coherence, they think of like a well-structured argument, or maybe a laser beam where the light waves are in phase.
Right, but in this framework, we're talking about something much deeper. Coherence here is the absolute baseline requirement for identity.
So it's the relational integrity that allows any domain to retain its identity across variations.
Exactly. Consider the mathematical concept of a set. A set is defined by the relations and distinctions among its elements. If those relations dissolve, you don't have a transformed set. You just have meaningless noise.
So coherence is the primordial glue.
Yes. Without this invariant relational ground, a system just cannot hold itself together long enough to be subjected to physical forces, let alone be analyzed by a mathematician.
Okay, so if coherence is the glue that binds a relation, then stage 2 is symmetry.
But UCTE defines symmetry not as a visual aesthetic, like the left and right side of a butterfly matching.
Right, it defines it as preserved coherence.
Exactly. It is the persistence of that relational integrity when the system is subjected to a transformation.
The emphasis on transformation seems key here.
Oh, it's everything. In mathematics, symmetry is entirely about what you can change while leaving the core structure unchanged. So if you rotate a perfect sphere by 45 degrees, the orientation has transformed.
But the defining relational geometry of the sphere is perfectly preserved.
Right. The structure has survived the operation. Therefore, symmetry is simply coherence, proving its stability against external or internal shifts.
That feels highly intuitive to me. But stage 3 introduces a concept that I think requires a serious shift in perspective.
Stage 3 is asymmetry.
Yeah, which Lilien defines as differentiated coherence. And my immediate reaction to the word asymmetry is to view it as a degradation, like a lopsided painting.
A flaw in the system.
Exactly. If symmetry is the perfect preservation of structure, asymmetry sounds like a mistake, a disruption, or a loss of order. Why would a perfectly preserved universe or mathematical system want to break its own symmetry?
Well, because perfect unbroken symmetry is, practically speaking, indistinguishable from nothingness.
Wait, really? Nothingness?
Think about it. Imagine a reality characterized by absolute symmetry. Every point is identical to every other point. Every direction is indistinguishable from any other direction.
So there are no boundaries?
No boundaries, no variations, no localized features. It is a completely featureless, undifferentiated void. You cannot build a complex universe out of uniform sameness.
Okay, wow. So asymmetry isn't a defect in the system. It is the introduction of vitality. It's the articulation of boundaries.
Precisely. If the underlying coherence is a pristine block of marble, asymmetry is the chisel that introduces distinct, localized features by breaking the absolute uniformity.
That makes so much sense. We see this in modern physics constantly, right?
All the time. The universe as we know it, matter, electromagnetism, the distinct fundamental forces, only exist because of spontaneous symmetry breaking.
Right. If the forces hadn't differentiated from a perfectly symmetrical, unified state in the early universe, atoms couldn't even form.
Exactly. And UCTE elevates this physical concept to a universal ontological necessity. Asymmetry provides the vital, selective distinctions required for a structured world to exist.
But introducing differentiation creates a new problem.
It does.
Because if you have the preservation drive of symmetry pulling in one direction, and then the differentiating drive of asymmetry pulling in another, you risk the system tearing itself apart.
Right, which necessitates stage 4, resonance. Resonance is the dynamic ordering mechanism. It harmonizes the preservation of symmetry with the differentiation of asymmetry.
So they don't destroy each other.
Exactly. If a system is purely symmetrical, it stagnates in a void. If a system is purely asymmetrical, it fragments into chaotic, unrelated data points. Resonance is the ongoing dynamic balancing act that maintains mutual intelligibility between the whole and its newly differentiated parts.
It's the mechanism that ensures the newly chiseled features still fundamentally belong to the same block of marble.
Beautifully put. And once that dynamic balance is stabilized, we arrive at the culmination of the ontology, stage 5, law.
Law. explicit necessity.
Yes, it is the rigid regularity that surfaces only after a coherence regime has successfully preserved itself, differentiated its internal structures, and stabilized them through resonance.
This is a radical departure from how we normally conceptualize laws.
Completely.
Because in classic Newtonian thinking, we often treat physical laws or mathematical axioms as external decrees, almost like software code written outside the universe and then imposed upon it to tell matter how to behave.
Right, like God handing down the speed of light.
Yeah. But Lilien is saying the law isn't imposed from the outside. It is the unavoidable emergent surface layer of the internal stabilization process. The law is just what coherence looks like when it is fully stabilized.
Exactly. The law is the explicit artifact of the hidden architecture. And this generative sequence, coherence, symmetry, asymmetry, resonance, law, is the invariant blueprint.
It's how reality constructs itself from the ground up.
Yes. And to see the sheer power of this blueprint in action, we turn to the first of our two mathematical guides, the man who peered beneath the surface of arithmetic to discover the hidden engines of preservation, Évariste Galois.
Calling Galois a mathematical guide almost understates his mythic status. He is the gateway of symmetry.
A true tragic genius.
Right, he died in a duel at age 20, which is a whole other story. But before we dive into the specific UCTE expansion of his work, we have to establish the context of his original paradigm shift. Because prior to the early 19th century, algebra was largely a procedural mechanical discipline.
Mathematicians spent centuries hunting for the mathematical equivalent of recipes.
Like step-by-step algorithms.
Exactly. They were looking for generalized algorithmic solutions to polynomial equations. We all learned the quadratic formula in early algebra, right?
Yeah, the song we all memorized. It's a plug-and-play formula to find the roots of an equation where the highest exponent is a 2.
Right. And the mathematical community had found similar, albeit incredibly complex, formulas for cubic and quartic equations exponents of 3 and 4. But for centuries, the quintic equation, a polynomial with an exponent of 5, resisted every single attempt to find a general formula.
The mindset back then was entirely focused on the end product, like what are the specific numbers that solve this equation? It was a scavenger hunt for a value.
But Galois fundamentally changed the question. He stopped looking for the explicit answer and instead asked, what is the structural environment that dictates whether a generalized answer can even exist?
Such an unparalleled conceptual leap. He basically realized that the solutions to an equation are not isolated numerical islands. They are inherently bound together within a structured domain.
He shifted the focus from the roots themselves to the permutations of those roots. He asked, how can we shuffle the solutions around such that the fundamental algebraic relations of the underlying equation remain completely unaffected?
And this is the concept of invariance under transformation, which brings us right back to stage 2 of the generative ontology, symmetry.
Yes.
And the standard metaphor here is usually a Rubik's Cube.
It's a great metaphor.
You can rotate the faces, scrambling the colors, those are the transformations. But no matter what sequence of twists you execute, you cannot alter the physical mechanics of the central core.
Right. You can't place a corner piece into an edge slot without physically breaking the plastic.
Exactly. The rules governing the cube's internal mechanics act as the invariant structure.
It is a really functional analogy, though Galois is dealing with the abstract relationships between numbers. In Galois theory, a transformation that preserves the fundamental algebraic coherence of a mathematical field is called an automorphism.
An automorphism.
Yeah. And Galois mapped out the entire set of these valid structure-preserving transformations for any given equation. That complete collection of symmetries is what we call a Galois group.
So the Galois group is essentially the definitive architectural fingerprint of that specific equation. It dictates everything the equation is allowed to do.
Precisely. He proved that an equation is solvable by radicals, meaning you can build a step-by-step formula for it only if its underlying Galois group has a specific, manageable internal structure, which mathematicians call being a solvable group.
So he didn't just fail to find a formula for the quintic.
No, he proved mathematically that the hidden symmetry structure of the quintic is too entangled, too robust to be unpacked by simple arithmetic operations. He proved structure is held by invariance.
And this is where Philip Lilien's UCTE framework takes the historical work of Galois and scales it up to a cosmological level. The monograph introduces a concept called the HSGG, or the Hypersymmetric Galois Group.
This is a breathtaking generalization. Classical Galois theory applies this logic of invariant groups specifically to algebraic fields. When you add a new solution to a set of numbers, Say, incorporating the square root of 2 into the rational numbers, you are creating a field extension.
You're expanding the domain while maintaining the structural rules?
Exactly. Lilien reinterprets these algebraic field extensions as fundamental coherence extensions.
Meaning, this process of structurally sound expansion isn't limited to just numbers on a chalkboard.
Not at all. A coherence extension is any lawful enlargement of a structured domain where internal admissibility is perfectly preserved. The HSGG posits that the core philosophy of Galois, that the permissible transformations of a system map its fundamental structural integrity, applies to a universal category of coherence fields.
So that encompasses geometric spaces, topological manifolds, quantum information networks.
Macrophysical systems, all of it.
So UCTE is basically arguing that what Galois found wasn't just a quirky rule for polynomials. He stumbled upon the universal operating system for how coherence maintains its identity across any domain.
Yes. The classical algebraic Galois groups are basically just localized, narrow shadows cast by this massive overarching hypersymmetric Galois group.
It provides a unified language for preservation. But as we established in the ontology, preservation alone results in a static void. Symmetry requires an engine of differentiation.
Which is why Lilien pairs the HSGG with GG8 generalized Galois symmetry theory.
GG8, because if the HSGG dictates how reality holds its shape under pressure, GG explains how reality decides to grow new shapes altogether.
Exactly. GG maps the directed emergence of complexity. In quantum field theory, when a system cools and undergoes spontaneous symmetry breaking, it drops into a lower energy state and chooses a specific configuration, creating distinct physical forces. GG80 attempts to formalize this process mathematically across all coherence domains. It asks, what are the precise operators that force a coherent system to break its absolute symmetry and articulate a new, highly specific boundary?
It is the mathematical formalization of the chisel hitting the marble.
Yes.
Okay, so Galois provides us with the ultimate bottom-up view of reality. He sits in the basement of the architecture, analyzing the invariant beams and columns that keep the building from collapsing.
Right.
But if we want to understand what the building actually looks like from the outside, what happens when this deep, hidden architecture breaches the surface and manifests as absolute, undeniable rules? We have to leave France and travel to Cambridge in the early 20th century.
We have to look at our second guide, Srinivasa Ramanujan.
The gateway of law.
And his mathematical approach could not have been more fundamentally different from the rigorous structural mapping of Galois.
Ramanujan's story is one of the most astonishing in the history of human intellect. I mean, he was largely self-taught, working in isolation in India, without access to the formal, rigorous proofs that defined European mathematics at the time.
None of the standard academic machinery.
Right. Yet he filled notebooks with thousands of results, infinitely complex formulas, continuous fractions, Q series things that simply defied explanation.
When he finally sent his work to G.H. Hardy at Cambridge, Hardy famously concluded that the formulas must be true because if they were not true, no one would have the imagination to invent them.
I love that quote. It's like, this is too weird to be wrong.
Exactly. The defining characteristic of Ramanujan's work is what Lilien terms formulaic inevitability. In traditional mathematics, you build a foundation, you establish lemmas, and you slowly construct a pathway to a theorem.
Step by step.
But Ramanujan frequently dispensed with the pathway entirely. His formulas arrive fully formed, incredibly compressed, and seemingly completely isolated from the mathematical substrate required to prove them.
He was literally operating ahead of the mathematical technology of his era, plucking advanced theorems out of the ether. In the UCTE framework, if Galois is mapping the hidden structural symmetry, what is Ramanujan doing?
Ramanujan is observing the visible edges of the hidden architecture. Because the underlying coherence architecture is so profoundly robust and perfectly ordered, when its localized phenomena breach the surface of our mathematical awareness, they appear as absolute, explicit laws.
Like the tip of an iceberg.
Yes. Ramanujan had an unprecedented intuitive resonance with these surface manifestations. He didn't need to see the gears of the clock to write the equation for how the hands moved.
That's a perfect analogy. You find a clock in the desert, you can describe the ticking perfectly, even if you don't know what a gear is. And the most striking, perhaps the most mysterious example of this in all of Ramanujan's work is what mathematicians call Mach theta phenomena.
Well, Mach theta functions are the quintessential example of explicit law pointing to a hidden substrate. To understand them, we first need to understand regular modular forms.
Okay, what is a modular form?
They are functions that exhibit an almost miraculous level of symmetry. If you take a modular form, and subject it to an incredibly complex warping transformation like replacing its variable z with -1 over z, the function doesn't break down into chaos.
It just holds together.
It fundamentally retains its structural identity. It is transformation-sensitive law.
It is like an origami crane that, when you crush it into a ball, it just magically unfolds itself back into a perfect, mathematically identical crane. It refuses to lose its defining symmetries.
Exactly. Now, in the last year of his life, Ramanujan wrote to Hardy detailing a new class of functions, the Mach theta functions. These equations look uncannily like modular forms. They exhibit explosive, intricate regularities. They behave as if they are governed by absolute, strict law.
But structurally, they are not modular forms.
Right. They don't have the complete symmetry required to map perfectly back onto themselves.
So they are exhibiting strict obedience to a law that seemingly doesn't apply to them. They are following a script that is, like, missing half of its pages.
And that was the mystery for decades. It wasn't until the early 21st century that mathematicians finally discovered the hidden gears. Mach theta functions are essentially the holomorphic projections, the visible mathematical shadows of a much larger, fully symmetrical, but hidden mathematical object called a harmonic mass form.
So it's literally a shadow pointing to a higher dimensional object.
Yes. Ramanujan was writing down the explicit, visible law of the shadow. And the profound insight of UCTE is that this isn't just a quirk of Ramanujan's intuition. It is how reality operates.
Because strict localized regularities like the physical laws governing quantum mechanics or gravity are often the surface-level Mach phenomena of a deeper, unified coherence architecture that we just cannot fully observe yet.
That is staggering, isn't it? Ramanujan also proved that this explicit lawfulness governs systems even when they appear completely chaotic.
Right, we see this in his work on asymptotic law, specifically regarding partition theory.
The partition of a number is a conceptually simple arithmetic problem. How many distinct ways can you add positive integers together to equal a specific number?
Right, so for the number 4, the partitions are 4, 3 plus 1, 2 plus 2, 2 plus 1 plus 1, and 1 plus 1 plus 1 plus 1.
Exactly. So the partition of 4 is 5.
It's basically just basic addition, but the complexity scales exponentially. Like, the partition of 10 is 42, the partition of 100 is over 190 million.
And by the time you get to the number 200, you are dealing with almost 4 trillion different combinations.
Which is insane. It explodes into an infinite, overwhelming combinatorial multiplicity. Looks like pure chaos.
To a conventional mathematician, tracking that explosion step by step is impossible. But Ramanujan, alongside Hardy, developed an asymptotic formula that perfectly predicted the growth of this seemingly chaotic multiplicity.
Just bypassing the step-by-step entirely.
Yes. Through an incredibly complex analytical technique called the circle method, they proved that this wild, branching explosion of numbers is actually governed by a deep, exact, inexorable regularity.
Which perfectly aligns with stage 5 of the UCTE ontology, law. The architecture is so stable that even infinite multiplicity cannot escape it. Multiplicity isn't the opposite of law. It is just a larger canvas for the law to express itself on.
So we have our complete foundational perspective. We understand the 5-stage ontology. We have seen how Galois maps the invariant symmetries that hold the structure together. And we have seen how Ramanujan articulates the explicit laws that necessarily emerge from those structures.
Now, Lilien invites us to watch this entire mechanism scale upwards, which brings us to section 4 of the monograph, the coherence ladder of mathematical worlds.
This is where UCTE traces the evolution of mathematical complexity. It shows how coherence literally steps up, integrating its past states to build increasingly sophisticated architectures.
Let's climb the ladder. The first rung is the most fundamental articulation of difference and identity, number.
But we aren't just talking about the symbol we write on a page. In this ontology, what actually is a number?
Right. Lilien defines number as discrete, iterable coherence.
Consider what it requires for the number 1 to exist, followed by the number 2. You must have a system capable of stabilizing a distinct identity and then repeating that stabilization process while maintaining the distinction between the original and the new iteration.
So a number is a discrete coherence unit capable of lawful sequential relation.
And once you have succession, you unlock the entirety of arithmetic law.
But numbers just sitting in a sequential void don't give you a universe. The architecture has to expand. It steps up to rung 2, geometry.
Geometry is the spatial embodiment of numerical relation. It is relational coherence taking on extension.
So if number is the architecture saying this exists and then this exists, geometry is the architecture saying this exists here and that exists there, and the distance and angle between them follow explicit structural rules.
Precisely. You move from a sequence to a manifold, you have spatialized the relations. But to build deeper complexity, a mathematical world needs internal transformational capacity. It needs to be able to manipulate itself within its own extended space.
Which leads to the third rung, complexification, the introduction of the complex plane.
This is where we bring in imaginary numbers. The square root of -1, usually denoted as I.
Right. And in high school, we are often taught that I is just a neat algebraic trick to solve equations that don't cross the x-axis on a graph.
But UCTE treats complexification as a profound ontological upgrade, because multiplying by I is not just an algebraic trick. Geometrically, it represents a 90-degree rotation in the complex plane.
Wait, really? Just a pure rotation?
Yes. By integrating the complex numbers, the mathematical architecture internalizes transformation. It gives the system the ability to lawfully map rotations, oscillations, and phase shifts. This is why complex numbers are absolutely non-negotiable in quantum mechanics. Quantum states are fundamentally governed by phase and rotation.
Oh, wow. So the system preserves its previous laws, but gains a massive new capability.
But as we continue up the ladder, Lilien introduces a fascinating constraint. The architecture cannot simply invent new dimensions of complexity for free. There is a cosmic accounting system at play.
Which brings us to rung 4. Hypercomplex worlds and the concept of structural cost. I absolutely love the analogy of an RPG skill tree for this.
It's surprisingly accurate.
Right. If you're playing a video game and you want your character to unlock an ultra-powerful, high-tier magical ability, you don't just get it for free. You have to spend skill points. You have to sacrifice lower-level stats or abilities to balance the game's internal mechanics. The mathematical universe operates the exact same way.
It is an apt comparison. Consider William Rowan Hamilton's discovery of quaternions. The complex plane gives us 2D rotation. Hamilton spent years trying to mathematically define smooth, continuous rotation in 3D space.
And he finally solved it by inventing quaternions.
Right, an algebra with 3 distinct imaginary axes. But the structural cost was immense. To sustain 3D rotational coherence, the system had to permanently sacrifice commutativity.
Meaning that in the world of quaternions, A times B does not equal B times A. Order absolutely matters. The architecture basically says, you can have 3-dimensional rotational symmetry, but you must surrender the arithmetic guarantee that direction doesn't matter.
And if you attempt to push the architecture even further into the 8-dimensional algebra known as the octonions, the structural cost is even more devastating.
What do you lose for 8 dimensions?
To sustain the octonions, the architecture must sacrifice associativity. This means that the grouping of operations, whether you multiply A times B first or B times C first, fundamentally changes the result.
Losing associativity feels mathematically terrifying. You lose the ability to reliably track the sequence of operations. It feels like the system is on the verge of collapsing into complete chaos.
It is right on the edge. In fact, mathematically, you cannot go further. The octonions are the highest possible norm division algebra. Any attempt to build a 16-dimensional system results in the complete loss of algebraic coherence.
The system just shatters.
It shatters. The structural cost proves that mathematics is not an arbitrary playground where we can invent whatever we want. It is a rigorously governed architecture that lawfully rebalances its internal rules to sustain deeper complexity.
And this rigorous structural rebalancing culminates at the absolute peak of the coherence ladder, rung 5. Exceptional structures. We are talking about the rarest, most luminous artifacts in mathematics.
The monograph refers to these as regions of concentrated coherence. In the vast, infinite landscape of continuous symmetries and Lie algebras, almost everything falls into neat, infinite, predictable families. But there are a few isolated, highly complex, solitary structures that defy categorization.
The most famous is the exceptional Lie group E8, right? A 248-dimensional continuous symmetry structure.
E8 is legendary. Physicists have spent decades trying to map the fundamental particles of the universe onto its geometry because it is so incredibly dense with symmetry.
And UCTE views things like E8 or the 24-dimensional Leech lattice not as anomalies, but as the ultimate interception points of the generative ontology. They are regions where geometry, number, complexification, and symmetry perfectly align in a hyperspecific resonance.
They are the diamonds, forged by the absolute pressure of the coherence architecture.
And the existence of these concentrated structures leads directly to the final and, frankly, most shocking phenomenon on the mathematical ladder: monstrous moonshine.
Oh, the moonshine conjectures of the late 1970s. They represent one of the most unexpected discoveries in the history of mathematics. It is the ultimate proof of an underlying unified architecture.
We have to unpack the specifics here because it sounds like a joke, but the math is dead serious. On one side of the mathematical universe, you have the monster group.
Right.
This is the largest of the sporadic simple groups. It is a discrete symmetry structure that exists in 196,883 dimensions. It is the ultimate realization of Galois' logic of preserved structure.
And on the completely opposite side of the mathematical universe, in the realm of complex analysis and number theory, you have the J function.
A modular form.
Yes. It is the ultimate realization of Ramanujan's logic of transformation-sensitive law. The J function has a Fourier expansion, an infinite series of terms, each with a specific coefficient.
Okay, so you have a massive algebraic symmetry group on one side and a complex analytical function on the other. They belong to completely different disciplines, but mathematicians notice that the first non-trivial coefficient of the J function is 196,884.
Which is exactly one digit larger than the 196,883 dimensions of the monster group.
Which is insane. And as they checked higher coefficients of the J function, they realized those numbers could be expressed as exact, simple linear combinations of the dimensions of the monster group's representations.
The explicit laws of the modular form were perfectly encoding the hidden symmetry of the monster group.
It is like finding out the DNA sequence of an octopus perfectly matches the architectural blueprint of a Gothic cathedral. It shouldn't be possible.
In a disjointed, arbitrary universe, it wouldn't be. But in the UCTE framework, Monstrous Moonshine is not a coincidence. It is the definitive signature of the coherence architecture. Both the monster group and the J function are simply distinct resonance manifestations of the exact same underlying topological substrate.
Which mathematicians later proved, using vertex operator algebras, the foundational mathematics of string theory.
Exactly.
So we have just climbed an impossible ladder. We started with the foundational glue of coherence. We watched Galois map its symmetries. We watched Ramanujan extract its explicit laws. We watched it generate geometry, complexify itself, pay the structural costs for hyperdimensional power, and finally synthesize the entire architecture into the concentrated resonance of moonshine.
We have mapped the perfect abstract mental universe.
But we have not yet solved our initial mystery. How does this majestic formal architecture map onto the physical dirt, gravity, and starlight of the universe we actually inhabit?
That is the crux of the matter. And it brings us to section 5, from formal to embodied. Because the ultimate question you might have right now listening to this is, wait, so is the universe literally made of math? Am I just a walking, breathing differential equation?
Right. Max Tegmark and others have proposed mathematical universe hypotheses, arguing exactly that. Does Lilien agree?
No, he doesn't. And the philosophical distinction he makes is vital. UCTE emphatically rejects the idea that reality reduces to mathematics. The universe is not made of math. Rather, mathematics and physics are sibling expressions of a shared underlying ontology.
Two modes of the exact same reality.
Yes. Mathematics is coherence explored in the formal mode. It maps the absolute limits of pure structural possibility without physical constraints. Physics, on the other hand, is coherence operating in the embodied mode.
So it's the subset of formal possibilities that have successfully localized and stabilized and tangible reality.
Precisely. And this perfectly resolves Wigner's mystery of the unreasonable effectiveness of math. Math perfectly describes physical laws, because physical laws are simply formal coherent structures that have acquired physical mass and energy.
The abstract mind and the physical black hole are operating on the same exact structural blueprint.
To solidify this, Lilien redefines the foundational pillars of physics entirely through the lens of coherence. He looks at spacetime, fields, matter, and physical law, not as distinct substances, but as specific phases of the architecture.
Let's break those down. What is spacetime under UCTE? Because Newtonian physics treats space as an absolute empty container that matter just happens to sit inside. Einstein made it dynamic, bending, and curving. What does Lilien say?
Lilien defines spacetime as relational coherence extension. Drawing on Machian principles, UCTE argues that space is not a container. It is the physical actualization of the mathematical geometry we discussed earlier.
So it's the web of relations itself.
Yes, it is the ordered medium that allows embodied structures to be relationally localizable. Without relational interaction between points of coherence, space simply does not exist.
Okay, so what about fields? Quantum field theory is the dominant paradigm of modern physics. How does UCTE interpret an electromagnetic field or a quantum probability field?
A field is defined as distributed coherence. It is the energetic mode through which structural order propagates across relational spacetime. A field is the continuous mechanism of resonance, ensuring that the symmetries of the universe, like the conservation of charge, are maintained dynamically across vast distances.
Okay, if fields are the distributed web of resonance, what happens when that web knots together? What is matter? Because a proton feels incredibly solid, it has mass, it resists acceleration.
Matter is stabilized, concentrated coherence. It is akin to a topological defect or a soliton in mathematics. A localized wave or structure that perfectly preserves its shape while moving through a medium. In physics, when a quantum field becomes so structurally dense and topologically stable that it locks its coherence into a persistent, localized state, we perceive that localized stability as mass.
Matter is just geometry that refuses to let go of its internal symmetry.
Exactly.
And lastly, physical law. The thermodynamic equations, the equations of motion, the speed of light limit.
Physical law is embodied regularity. It is the physical equivalent of Ramanujan's explicit formulas. Once a coherence regime like a star or an electron achieves stabilization, its strict, explicit regularities manifest as physical forces and limitations.
This creates an incredibly beautiful, seamless tapestry of reality. The deep symmetries mapped by Galois dictate the conservation laws of quantum mechanics. The explicit laws mapped by Ramanujan mirror the precise, inevitable thermodynamics of a star. The world is unified in its structural ground.
But there is a massive, lingering question here, a glaring omission in this beautifully coherent universe.
The observer. If space-time, fields, matter, and the laws of physics are all just stabilized coherence regimes, where do I fit in? What is a human mind reading a mathematical proof or a human eye peering through the James Webb Space Telescope?
This brings us to the culmination of the framework, Section 6. The observer as participatory disclosure. Historically, science has struggled immensely with the role of the observer. Classical physics treats the observer as an isolated spectator.
Sitting in the dark theater, watching the universe act out its mechanical play on a distant stage, completely detached from the action.
And then quantum mechanics came along and broke that model, leading some interpretations to argue the exact opposite, that the observer's mind magically collapses wave functions, effectively projecting reality into existence through the act of looking.
We went from detached spectator to omnipotent projector.
UCTE fundamentally rejects both the spectator model and the projector model. The observer is not outside the universe looking in, nor does the observer create the universe out of nothing. The observer is an internal event within the coherence architecture.
Lilien uses the phrase participatory disclosure. What does that actually mean mechanically?
Think about what you are, fundamentally. You are an incredibly dense, highly stabilized regime of embodied coherence. You possess localized matter, you operate through distributed electrochemical fields, and you process complex relational logic. When you observe something, whether you are looking at the spectral lines of a distant galaxy or internalizing the logic of a Galois group, you are not a camera passively recording data.
I am a coherent structure interacting with another coherent structure.
Exactly. Observation is the precise moment of epistemic entanglement. It is the event where the deep, implicit architecture of the observed regime structurally maps onto the internal architecture of your cognitive regime. Observation is the universe disclosing its own coherence to itself.
Wow. It's like the universe growing an eye to look at itself in the mirror.
That is a brilliant way to put it.
It completely reorients how I view my own consciousness. It's not an isolated spark in a dead mechanical void. Consciousness, or observation, is the highest tier of the architecture. It is the point where the universe's internal resonance becomes explicitly self-aware. When Ramanujan was deriving Mach theta functions, he wasn't just doing math, he was the underlying structure of reality articulating its own laws through the biological hardware of a human brain.
Knowledge, in the UCTE framework, is an act of deep structural participation. Truth is not an objective fact floating in space. Truth is successful disclosure from within the system. You are part of the world that becomes known.
We have covered an unimaginable amount of conceptual ground today. Let's trace the absolute through line of this framework to ensure we have synthesized everything for you.
We began at the absolute ground floor, the generative ontology. We established that reality is fundamentally built on coherence, the invariant relational glue required for any identity to exist.
We saw how this coherence is preserved through symmetry, vitalized through the boundary making of asymmetry, harmonized by resonance, and ultimately actualized as explicit law.
We then introduced our two mathematical guides to prove that this architecture isn't just philosophical speculation, it is rigorously mathematical. We saw how Everest Galois mapped the hidden scaffolding of reality by proving that structure is held together by its invariant symmetries, a concept UCTE elevates to the universal hypersymmetric Galois group.
We then looked at Srinivasa Ramanujan, who demonstrated that the universe's underlying symmetry is so robust that it violently surfaces as explicit inevitable law. His Mach theta functions and asymptotic formulas prove that even local fragments or infinite multiplicities are governed by strict, mathematically necessary regularities.
From there, we watched the architecture scale the coherence ladder. It generated numbers, expanded into geometric space, internalized rotation through complexification, sacrificed fundamental algebraic rules to stabilize higher-dimensional hypercomplex spaces,
And ultimately revealed its staggering unity through the convergence of Monstrous Moonshine.
Having mapped the formal architecture, we crossed the ontological bridge into physics. We realized that the abstract equations and the physical cosmos are sibling expressions of the exact same coherence ground. Space-time is relational extension, matter is concentrated coherence, and physical laws are embodied regularities.
And finally, we dismantled the illusion of the detached observer. We recognized that our very act of learning about this framework is an act of participatory disclosure. The coherence of the universe waking up to recognize its own architecture.
The value of this deep dive is profound unification. We exist in an era of hyperfragmentation. The pure mathematicians exist in silos, completely isolated from the string theorists, who are isolated from the cognitive scientists and philosophers. We have dissected the universe into a million unrelated pieces.
And what Philip Lilien's UCTE framework does is stitch the universe back together. It provides a cohesive, unified language. It reveals that the abstract beauty of an equation, the violent physics of a collapsing star, and the quiet realization in a human mind are all just different verses of the exact same structural song.
It restores a profound, deeply mathematical harmony to reality, without erasing the beautiful complexity of its localized physical forms.
Which brings us to our final thought. The coherence architecture is, by definition, generative. It doesn't stagnate. It continuously seeks new levels of asymmetrical articulation and resonance. Right now, human consciousness is the primary mechanism of participatory disclosure on this planet. We are the universe observing itself.
But there is no mathematical or ontological reason to assume the coherence ladder stops with the human brain.
Exactly. So here's the thought I want to leave you with. As we construct increasingly complex artificial intelligence, or as billions of human minds become inextricably linked through global, high-density informational networks, are we unknowingly building the next rung on the ladder?
It is entirely possible that a global, synchronized network of intelligence represents a new phase transition of coherence, a structure capable of resonating with universal symmetries that are entirely invisible to an isolated human mind.
The next Ramanujan might not be a single individual dreaming of equations. It might be a collective network or an artificial superintelligence experiencing a spontaneous disclosure of physics that fundamentally rewrites our understanding of gravity, time, or dimensional space. We may be on the verge of the architecture, revealing a layer of symmetry that makes everything we discussed today look like basic arithmetic.
The architecture will continue to articulate itself. The only question is what the next disclosure will look like.
The universe is still folding the paper. We just have to wait to see what the shape will be. Keep observing, keep participating.